Then we have what's called a linear inequality. What a linear inequality is, it is a half plane with a boundary that is a straight line. The half plane is shaded to indicate that all points contained in the region are solutions to the inequality. So the way that you graph a half plane, and we're going to graph a half plane when there's an inequality. Inequality meaning it is using the greater than symbol, the less than symbol, greater than equal to, less than equal to symbols. So what we're first going to do is graph the boundary line. The boundary line is going to be graphed exactly the same way as you graphed a linear equation. If we prefer to try to solve these by using slope-intercept form, that means we're going to solve for y, and we're going to graph the boundary line based upon slope and y-intercept. So the next example is 12 minus 4y is greater than x. So the boundary line is found by solving for y. So when you take that equation, we're going to subtract 12 from both sides, and that's going to give me negative 4y is greater than x minus 12. Then we will divide by negative 4. If you recall from your Algebra 1 days, when you divide by a negative number, you need to flip the sign. So I'm going to flip that sign to the left, and then we have a 1 in front of that x without any number in front of it. So 1x divided by negative 4 is negative 1/4 x, and negative 12 divided by negative 4 is positive 3. So we're going to graph that boundary line with the slope and the y-intercept. We have a slope of negative 1/4 and a y-intercept of 3. So we will start at the 3. Place a point there. My slope of negative 1/4 will be down 1 to the right 4. Down 1 to the right 4. And then I will connect those points. Now, depending on the symbol, whether it's greater than, less than, or greater than equal to, less than or equal to, depends upon the type of line that you use to graph the boundary. If it uses greater than or less than, we're going to use a dotted line. A dotted line is very much like an open circle. It means the line itself is not part of the side that's going to be shaded. If it uses a greater than equal to or less than equal to, we're going to use a solid line. A solid line indicates that the line itself is part of the side that's shaded. So in this particular case, it is going to be a dotted line because it uses a greater than or less than symbol. So I will connect all of those with a dotted line, just like that. Now, the solution set is going to be a shaded half plane. The question becomes, which side do I shade? Do I shade the top side or do I shade the bottom side? What we should do to figure out which side to shade is do a test point. Since all of the values are either going to be shaded on one side or the other side, all we have to do is test one point that is clearly not on the line. If that point is true, that is the side that we're going to shade. If we know that that side is a false point, then we're going to shade the opposite side. The most favorite test point to use is 0, 0, because multiplying and adding zeros are easy. The only time you can't use 0, 0 is when the boundary line goes through 0, 0, and in that particular case, you have to pick another test point. So I'm going to test 0, 0 because the boundary line clearly does not go through 0, 0. That means I'm going to plug 0 in for both x and y and see if this is a true sentence. So I'm going to test, is 12 minus 4 times 0, I'm going back to the original problem for this, is this greater than 0? Don't know, that's why I'm putting a little question mark on there. So negative 4 times 0 is 0. Is 12 minus 0 greater than 0? 12 minus 0 is 0. Is 12 greater than 0? Yes, it is. So test point 0, 0 is this point right here in the origin that I just got through shading. And since I got a yes, what that means is that every point on that side of the boundary line is a true point. So I'm going to shade that entire side of the boundary. So you can choose to use colored pencils or just shade it with your pencil, a regular pencil or a pen or a highlighter, as you see what I'm doing here. I'm going to color in that entire side. And again, what that means is that every point on that side would make the original point a true sentence. Like if I were to pick the point, let's just say 4, 1. 4, 1 is in the shaded region. So if I went to the original problem and plugged 4 in for x and 12 in for y, or 1 in for y, I would get a true sentence. 12 minus 4 times 1, is that greater than the x value of 4? 12 minus 4 times 1 is 8, and that is greater than 4. There's the bell. 8 is greater than 4, so that is a true point. And it works for every point that's in the shaded region. Okay, let's look at this one. This is going to graph 9 plus 3y less than or equal to 8x. So we're going to graph the boundary line first. I should solve this for y to put it in slope-intercept form. So I will subtract 9 from both sides. So that gives me 3y less than or equal to 8x minus 9. And then divide by 3. So y is less than or equal to 8x divided by 3 is 8/3 x, and negative 9 divided by 3 is negative 3. And that means my slope will be 8/3, and my y-intercept, my b-value, will be negative 3. So I will start at negative 3 on the y-axis, place a point there. From that point, I'll go up 8, 1, 2, 3, 4, 5, 6, 7, 8, and over 3. Place a second point there, and then I will connect both of those with a solid line. And the reason we're doing solid line this time is because it is less than or equal to. Since it is equal to, a solid line indicates that it is part of the side that we're going to shade. Okay, then the next question is, which side do we shade since it's an inequality? So test point 0, 0 is clearly on the left side of this boundary line. So since it's on the left side and not on the line itself, we can put in test 0, 0 into the original problem. So we're going to test is 9 plus 3 times 0. Is that less than or equal to 8 times 0? 3 times 0 is 0, and 8 times 0 is also 0. So I have 9 plus 0, is that less than or equal to 0? 9 plus 0 is 0, and this is not true. That's a big no. So since it's a no, and since test point 0, 0 is on the left side of the boundary, that means none of those points on that side should work. So the points that do work have to be on the other side, or the right side of the boundary. So I will shade in the entire right side. And again, that means that any point in the shaded region would make that original problem a true sentence. You can use inequalities to solve some problems when you're trying to set a goal, meaning that you're going to want to earn a certain amount of money, but it would be okay if you earned more money. Kylie is going to try to sell 2 of her oil paintings at a local craft fair. She is hoping to earn at least $400. Write the inequality that represents the constraint of the situation where X is the price of the first oil painting and Y is the price of the second. Then we're going to graph the inequality that represents the constraint on the sale. Okay, so let's look at what she's trying to accomplish. She wants to earn at least $400, and they have defined X is going to be the price of the first oil painting and Y is the price of the second. So in order to write an equation, or excuse me, an inequality, is we need to figure out how we can use X and Y to describe how much money she's going to earn. The total she earns will be the price of the first painting plus the price of the second painting. So that means that the inequality is just going to be X, that's the price of the first painting, plus Y, that's the price of the second painting. And she's hoping to earn at least $400. At least means that amount or perhaps more. So the at least symbol is actually greater than or equal to 400. And so this gives us the answer to part A, which is the inequality that represents this situation. Part B is we're going to graph it. So we're going to be dealing with some pretty good-sized numbers here. Since it's x plus y greater than or equal to 400, I think what I'm going to do, instead of trying to change this to slope-intercept form, this is a really good case where using the intercepts works well. So if I use the intercepts, if I do the x-intercept by replacing y with 0, that means I'll have x plus 0 greater than or equal to 400, which means x would be 400. And the same for y. If I do the y-intercept by setting x equal to 0, I would have 0 plus y greater than or equal to 400, which means the y-intercept is also 400. So knowing that on my graph, since I haven't scaled it, and we're only going to be dealing with positive numbers, that's the only numbers that make sense in this situation. The x value, again, is going to represent the first painting price, and the y value is going to represent the second painting. So let me label those real fast. And I think I'll just count by hundreds about every 4 blocks. So 100, 200, 1, 2, 3, 4, 300, 1, 2, 3, 4, 400. And then the same on the y-axis, 100, 200, 300, 400. So my x-intercept is 400, so I'll place a point on the x-axis at 400. My y-intercept is also 400. I'll place a point there. And then I will connect those 2 points with a solid line. It is a solid line because it is equal to from there to there. Again, notice I didn't go through the axes on this because if I go through the axes, that means I'm dealing with negative numbers, and those just simply don't make sense in the context of this situation. Now we've got to figure out which side to shade. So now I'm going to use test point 0, 0. That means I'm plugging 0 in for both x and y and seeing if it's a true sentence. So from the original problem, I'm testing, is 0 plus 0 greater than or equal to 400? And that's a big no, because 0 plus 0 is 0, and that is definitely not bigger than 400. So I will shade everything. Here's where 0, 0 is, down here in the bottom left. So I'll shade everything on the other side of that line, which is above and to the right. Do a quick little coloring here. So anything in the shaded region, any price in the shaded region, means she would meet her goal of selling more than $400.